What's going on, everybody? It's Adam Shlomi from SoFlo SAT Tutoring. I'm here to show you how to solve one of the trickier math problems that I've come across. If you were unable to get this problem, don't be alarmed. Definitely one of the harder ones on the SAT, but one that's going to come up, so it's something you have to be prepared for if you want to be successful. This is a really interesting problem because it might seem really tough at first, and the first time you say, well, I don't even know, where to begin or how I should get started. But once we show you a really fast and simple way to get through the problem, you're going to realize that it wasn't that difficult and the math itself isn't too challenging. This is math that you can do in your head even. The real challenge with this question is, how do I get started? What is the right way to begin cracking open this solution? Before we go any further, I want to let you guys know that the answer is 6. I'm not going to wait until the total end of the video to let you know what the answer is. So the answer is 6. So I'm going to pull this up on a digital whiteboard that we use at SoFlo, so it helps explain how we do a lot of the math questions and how we try and show our work with our students. Now that we're in the digital whiteboard, I want to tackle this question by writing out all the information that they give us and diagramming as much as I can. I want to start with this radius. So we see that this circle has a radius 10, which means that any length from the edge of the circle towards the center is 10. So this line has a length of 10, and it also means that this line from 40 to HK has a length of 10. The next thing that we can figure out is the midpoint. So we have point 40 here and point 20, 0 here. If I asked you to figure out what is the middle point between 40 and 20, we would use midpoint formula to figure that out. We see that we have a point 40 here and a point 20 here. The midpoint is going to be when we add up 4 plus 20 and divide by 2. So 4 plus 20 is 24, divided by 2 is 12, and that means that at point 12, right about here, is where these 2 points intersect. And so a quick refresher on midpoint formula for those who forgot. You add up all parts of both points and then divide by 2. So we would add 4 to 20 and get 24. When we divide 24 by 2, we get 12. We would add 0 plus 0, divide that by 2, and we would get 0. So we just say, here's what the leftmost is, here's what the rightmost is, what would be right in the middle. So now we've diagrammed the radius and we've diagrammed the midpoint. This is the area where I think a lot of people are going to get stuck. Now it's not very clear what we should do to be moving forward. And this is where practice comes into play. When you've been doing a lot of SAT practice questions and working through and starting to recognize the patterns on the test, you can see that this is probably the question where you're going to have to graph something out and play around a little bit. So I always encourage my students to write on the test as much as they can. What I'm going to start doing here is writing out, and I'm going to create a 30, 60, 90 triangle, and that's going to make this question really easy to solve. So now I'm creating the 30, 60, 90 right triangle. I'm creating a line from 40 to 12. So this line is going to have a length of 8. Then we know that our line from 40 to the center of the circle, HK, is length of 10 because this is the radius. Let's write a little r here so we can remember that it's the radius. And now we're trying to figure out one more. We don't know what this length is. And this is really what we're trying to solve for because we want to get the value of k. And so h was pretty easy to solve for. H is the midpoint here of 12. But k is the height. K is going to be the height of this triangle. And so now that we have 2 points, with 2 lengths on this 30, 60, 90 right triangle, it should be pretty easy for us to solve for this height. The way that we're going to solve for it is using Pythagorean theorem. And Pythagorean's theorem is the kind of formula you learn in school A lot of kids know it, but sometimes they forget it if they haven't taken geometry in a few years. This is the kind of thing where we can remind students, hey, you forgot this rule, but here it is again. Don't freak out too much, and we're able to get a lot of progress pretty fast.
So a quick refresher on Pythagorean's theorem. It helps us find the length of the sides of a right triangle. It's a squared plus b squared equals c squared. And c squared is always the largest length on the triangle, the one opposite the 90-degree angle. So in our situation, this 10 would be our c squared because it's the largest side and it's opposite the 90-degree angle. So now we're going to plug in. We'll say a squared is what we're trying to solve for, we're not sure. We'll say b squared is one of the lengths, so we'll say 8 squared. And then we'll say that c squared is our largest length, it's this 10, so 10 squared. We'll do the math again, 8 squared plus 8 squared is 64, is equal to 100, which is 10 squared. Subtraction, then we get a squared is equal to 36, and then a is equal to 6. So I'm going to repeat that a little bit just so we make sure we got where we need to go. A squared plus b squared equals c squared is Pythagorean's theorem. It says that the two small sides of a triangle, when squared, will be equal to the largest side of the triangle, squared, but only for right triangles. Here we have a 30, 60, 90 right triangle that we created ourselves so that we could solve for the height of this triangle. We plug in 8 for one of the lengths, and we plug in 10 for the largest length because it's opposite the right triangle. And because we have these two lengths, we're going to be able to solve for our third length, which is a. So now we have a squared, we have 8 squared, and then we have 10 squared. We work out the math, and we find out that a is equal to 6. So if this length, which originally was a question mark, is now equal to 6, that means that the point from 0 to this spot at HK is 6. So the height, if this height is 6, then that means the coordinate also has to be 6. And that's how we were able to solve for the value of k.
Once we break it down using the Pythagorean theorem, using the midpoint formula, and using the radius, we can find out what two of the lengths of this triangle, and then once we get two of the lengths, we're able to solve for a third length. Not too tricky, but you would just have to realize how to use the triangle, and that'll make the whole problem a lot easier to solve. Definitely one of the trickier questions I've seen on the SAT. It incorporates a few different things that we have to know, like the radius of a circle, midpoint formula, and Pythagorean theorem. And so in this way, it's a combination of a few different skills that the SAT is always testing you on. But if you want to be a 90th percentile score or above, you're going to need to be able to get questions like this correct. But don't worry, there's a lot of other easy questions on the SAT. This is probably one of the harder ones that you're going to struggle to solve a little bit. And it's going to take a lot of practice to start getting questions like this right consistently. And if you're interested in trying out SoFlo and seeing how we can help you raise your SAT score, give us a call, 954-654-9777, or check out the website in the description. We're always here to help. Peace.